have in our midst the President of the University of Technology, Dr. Kevin Brown. We have with us our Vice Dean of the Faculty of Computing and Engineering, Dr. Balvin Tarp. Head of School of Engineering, Mr. O'Neill Josephs. We have one of the main organizers for this lecture series, Dr. Percival Stewart. We have our guest lecturer this morning with us, and Dr. Nadine Maitland. We have also lecturers with us. We have Professor Marva Blankson from the Civil Engineering Department, and Mr. Allen from the Civil Engineering Department as well. Also, Dr. Blissett. From JSIF, Miss A.C. White, and also Mr. Dane McLean. JSIF have been our main partner in this event for the past, I think, 3 sessions now, and we are looking forward to a long partnership to come. So, without further ado, I'll ask, to our wonderful guests and students. I want to welcome you all to this lecture series. Today's lecture will be on AI, artificial intelligence, smart engineering. Without further ado, I'll ask Professor Marva Blankson to offer prayers.
Good morning, all. Let us pray. Almighty and everlasting God, we give you praise, we give you thanks, acknowledging you, Lord Jesus Christ, as the great I am. And as we gather here this morning, we want to give you thanks for our lives and for our health and the strength. Thank you, Lord, for this opportunity to meet and share in this lecture on artificial intelligence. We ask, Lord Jesus, that you use the presentation here to enrich our knowledge in artificial intelligence. We give you thanks and ask your blessings on the initiator of this program, the planners, the sponsors, all participants, and especially on the main speaker, Dr. Nadine Maitland. May you, Lord Jesus Christ, continue to use them to direct this program successfully to the end. So, Lord, that you help us to use the knowledge gained from this lecture to achieve the plan for the University of Technology and for the enhancement of development in the construction and engineering sector. We give you thanks as we place these requests in your hands, asking your blessings on each and every one of us here. In the name of Jesus, we pray. Amen.
Amen. So today promises to be a very informative session. So I encourage you to remain engaged and curious as we divulge into this innovative application of AI in engineering and how it is shaping the future of our built environment, especially when it comes to infrastructure resilience and recovery efforts after a disaster event. So at this time, we're going to have remarks from Dr. Percival Stewart.
Good morning. Dr. Kevin Brown, President, University of Technology. Dr. Balvin Thorpe, our Vice Dean, Faculty of Engineering, and also Vice Dean to Department of Civil Engineering. He's always with us. And our HOS at a school, Mr. Cummins, Mr. O'Neill Joseph, who is always with us, always supporting civil. You know, the strength is behind coming from him. He'll curse you off, but he's here fully supporting you. Ladies and gentlemen, colleagues, earthquake is not a predictive phenomenon. And we all know, unlike hurricane, you read it on a chart and you see it coming, and they say batten up and clean the drains for all of that. No, it's not like that. It's something that will hit you momentarily. And then it's after that you have the disaster. Like they said, earthquake don't kill anybody. It's the after effect. The building tumble down, the earth open up, the bridge fall, the water supply, etc., etc. So it is prudent on the University of Technology, in particular the Civil Engineering Department. When we looked at earthquake phenomena, we decided last year, and ironically, gentle people, next month mark 1 year anniversary, we're at it. Right, 1 year anniversary. We started with a big symposium. Earthquake topics is inexhaustible. You cannot, because it affects so many things and so many lives. So 1 year ago, let me proudly say 1 year ago, right, Dr. Thorpe? 1 year ago, we decided, we got the charge from our dean then, from faculty, that we should be doing something. It turns out that they pick on the weakest guy, I think that was me, to come up with a topic. And I was studying the earthquake phenomena worldwide, looking at the trend and looking at the carnage. And I said, where can you take position itself in all this thing? The university has the monitoring unit, big task for them. They'll tell you how many, the strength of it at the time and epicenter, etc. But that's all. And the fact that you can't predict it, so what do we do as ordinary, citizens? Just sit and say, okay, at 7, 8, Tom dead, Mary get broke up. No, we have to build resilience in our lives first, in our systems, so that we can save lives and, get back to the norm that we have, or even better. And that's what the whole lecture series is about. So we decided to pick elements, highlight them, and focus, investigate them, and bring it to you, our audience, as to what we find and workable. So when the 5.6, that was it? Yeah, when that hit, we got a lot of calls. Hey, what can we do? So Mr. Cummins and I from our department, and in fairness, this is why I support our HOS, O'Neill Joseph. He was the first one call and say, earthquake 2.0. We must have that one right away. He was the first person who called. And then we get calls from people, what can we do? And we decided, okay, since they are more concerned about their infrastructure, their superstructure, the house, buildings, we decided that looking at all implements that goes into the civil engineer buildings and all that, we said, we asked Mr. Peter Jarvis, a leading structural engineer, who had experience with dampers in structures, sway restrainers. These are some big things in engineering with it. And he said he would be happy to. So he was our guest lecturer at the last lecture, and he delivered greatly on what? It was then many people didn't know that building can sit on bearings. Okay, they said bearings, yeah, and it helps. It's an earthquake resistant stuff because it's rock and it's rock back. Because when you sway and the thing stiff, it pop, So you need it, but you don't want it too flexible till you go down to the ground. So that bridge, dampers, stiffeners, all work instructions. He delivered that lecture nicely. We were going to move on to our hospital systems. Why? Because we noticed in COVID, 2,500 were affected, and the hospitals were all shut in the island, 2,500. And it's just a cold and flu. When phenomena like earthquake or other disasters or hurricane comes along, what will happen is only more than that. So that highlights to us that, hey, our health system are there resilience in this? We don't know. So we are investigating that. And so the next lecture after this one will be in that health system to see how resilient are we build it. Remember, gentle people, look at it this way. When Turkey last year, I think it was last year, January, February, when it struck in Turkey, it was around 58,000 people lost their lives and many damaged. Building for one whole city almost. But guess what? They were back running so much so that Tayyip Erdogan won the election in that month. I can tell you this, nowhere in the world you'll have catastrophe and the sitting government win back. They had built-in resilience in their system, so the people don't even blame government. It was there for them, and they get back to their normal quickly. Yes, some might say Turkey is a NATO country, big money, but that's so big. Look at Haiti. If Haiti did have a little bit of resilience, the carnage wouldn't be happening over 13 years to date since that earthquake devastated Haiti. Nothing happens. And this is where you get warlords coming. When people's lives are not built back quickly, as is resilience topic, what you get is chaos, anarchy, and there will be a leader, the bad man. We don't want this nice little paradise named Jamaica. No matter what catastrophe, turn to that. Because even Jamaica forgot to help them now, as you might have heard in the news, right? Because something has to be done. They will never come back. Marrakesh, the other day, got, I think it's a 7. And what, anybody know what Marrakesh said? Can't build back 49 years before you can build back Marrakesh. So the government just leave it like 49 years. I don't think we can survive even 10 years to build back Jamaica, or 5 years. So we're praying for the best, but we know catastrophe can face us, and we have to prepare. And I say that to say why we are so, UTech is heavily on the resilience and the recovery. I am going to close my opening remarks. I did that to open your ear because we're going to hear from a very knowledgeable lady, Dr. Maitland, soon. And it's news to our ears, but it is not worthwhile looking at. It's the way we'll have to go. Because the way we go about recovery and the way we do resilience in these modern times, I don't think we can make it. And that is why we skip the hospital lecture and bring AI, resilience and recovery, to you all. Ladies and gentlemen, thank you for coming and enjoy the lecture.
That's Dr. Percival Stewart, an engineer and philosopher. And he could sit and talk to you about earthquake and recovery for an entire day. So when you have time, just go over and have a talk with him. We'll have remarks from our Vice Dean, Dr. Balvin Tarp.
Good morning, good morning. Morning to welcome to my UTech family and welcome to those who are, I guess we're online as well. I want to thank our president, Dr. Kevin Brown, for being here. One of the things that I like about Dr. Brown is that anything engineering is always here. And we welcome you, sir, even when we haven't extended our hand to welcome you, all right? Head of School Joseph, our distinguished guest lecturer today. I sit here and I'm thinking about AI, but I know that I'll be hearing a lot more about AI and its capability after knowing Dr. Maitland as a person who I know. You're going to hear AI and it's going to be impactful. So add that on top of earthquake, as you're going to have a shake-up this morning, all right, in our presentation. All right, so good morning, everyone. As the Acting Dean and Vice Dean of Faculty of Engineering here at UTEC, it's both my honor and pleasure to welcome you to today's distinguished lecture, the title is very befitting, Earthquake Resilience. Are we ready? So you heard Dr. Stewart mention all these places and what happened. And I don't want to leave out the telecommunication sector, Dr. Stewart, and the civil department, because I'm sitting here and I'm looking at some people, especially young people, and you see them, almost everybody on their devices, The power of telecommunication, everybody is there and you're using your mobile devices. And what happens if we have this, some earthquake that, how will it impact your adaptability if our telecommunication infrastructure becomes, damaged to a great extent? So I want you to plan that as a part of it, to hear what our telecommunication companies are doing and can do in terms of your series. In a world where natural disasters seem to be more frequent and more severe, the topic of our discussion today is not just timely, but, in my view, crucial. Jamaica, like many island nations, and Dr. Stewart mentioned about Haiti, we've been lucky, we've been lucky as neighbors to Haiti. It is no stranger that we have these type of natural disaster. Our resilience, our readiness to face, and our capacity to recover from such events are of paramount importance. The Faculty of Engineering and Computing, through the Civil Engineering Department, is committed to fostering a culture of preparedness through knowledge and innovation. And, we welcome these type of series, Dr. Stewart, Mr. Cummings, and team. As the knowledge and information that are provided here will only strengthen us as not only a university, but hopefully a community and a country to be ready and prepared for the event of a natural disaster such as an earthquake. Our main aim is to continue to build resilience in our society, one that is not only ready to respond effectively, but also adapt and transform in the face of such challenge as a earthquake. We felt the 5.6, and we were here shaking at UTEC. The funny thing about it is that, a couple weeks after that, there were a 7 point something in, I think it was somewhere in Japan. And because of Nepal, thank you, President. And, they had a lot of course, loss of life, but because of the fact that they were resilient, I think that's the main thing that this entire civil department is trying to make us here and the entire Jamaica be aware of, that the resilience, what you put, how you plan, how you have things put in place is what is going to make us survive some of these eventualities. As we proceed with the lecture, I encourage each of you to reflect on the role you, as individuals, students, educators, citizens, professionals, can play in building a resilient Jamaica. Let us all commit to taking and excerpts from these discussions and insight from these talks and learn from today and apply them to make tangible differences. So in closing, I extend sincere gratitude to our guest lecturer, Dr. Maitland, and the Civil Engineering Department for their expertise and for organizing this distinguished lecture. Thank you all for joining us today. In this critical conversation. Together, we can have a safer and more resilient future and a more resilient Jamaica. Again, thank you for coming, and let's hold on to our seat, because I think this one is going to give us a little shake when our guest lecturer gives us our presentation. Thank you so much, ladies and gentlemen.
Thank you, Dr. Tarp. Last night I called the president just to give him a reminder of this morning's session. And when he answered the phone, I realized that he didn't need reminding. He said to me that I'm actually looking forward to it, Mr. Cummins. And he started telling me all the times when it will start and what will happen. And so I'm happy that he's so engaged in the activities of the Civil Engineering Department and the School of Engineering. And so at this time, help me to welcome the president of the University of Technology, Dr. Kevin Brown.
Morning. Thank you, Mr. Cummins. You know, you guys are going to get me in trouble now. And so I have to say that I have a strong interest in all faculties and colleges, all programs and modules, everything that affects our university. But of course, I'm a former student of this university. And I happened to pursue a diploma many years ago in the School of Engineering. And I'm an engineer, so I think, you know, when other presidents were here, they also leaned towards their specialisms, and you'll have to forgive me if I do that from time to time. But I remain the university's president. So let me first acknowledge Dr. Percival Stewart, program leader. And I was asking, I'm saying, well, I'm sure Dr. Stewart has retired, but he's still here. So lifelong, shall we add that to his title? Dr. Stewart, lifelong lecturer, program leader for civil engineering. And I know civil engineering, that department is a passion of his. So congratulations, Dr. Stewart, on this distinguished lecture. And I look forward to hearing other speakers as the series continues. I also want to acknowledge Dr. Balvin Thorpe, who just spoke to you. He's Vice Dean, as you know, responsible for graduate programs, wears many hats. He sits on the Jamaica Institute of Engineering, their committee, their exec, sits on the IEEE as well, and involved in many things. And I keep saying, these are examples of what I want to see from all our academics. Go out there, get involved, put UTEC's name out there, but more importantly, put yourself out there so that you become the expert that industry and the public sector call on, and it reflects on our university, right? So, Balvin, keep doing what you're doing, but please remember, don't be late for your lectures. All right, and of course, Mr. O'Neill Josephs, not saying he's been late in the past, but so I'm just joking with him. Mr. O'Neill Josephs, head of School of Engineering. Again, I think perhaps someone who's been quite committed to UTEC. President of the Jamaica Institute of Engineers, also someone who's very active external to UTEC and setting that example. He and the GIE have declared this year as the year of engineering. And we need to be aware of this because nothing happens on this planet without engineers. I know you'd probably say it's a stretch to put engineers next to God, right? But next to God, who created the natural environment, It's the engineers now who have manipulated it into what we have. This lecture theater is because some architect dreamt it up, structural engineers designed it, and the builders built it. We can travel across the Atlantic Ocean at will because aerospace engineers decided to dream that we could fly like birds. And we drive our motor cars and we take it for granted. Engineering is central and focal to the development of any country. And this is why I'm so proud to be part of UTech, because we are doing what Jamaica needs, more engineers. And of course, we are transitioning into this technological age, which is why Dr. Maitland is here to speak about artificial intelligence. But I want to underscore the importance of engineers. Because as Jamaicans, we tend to, put big significance on the doctors, right? Keep us healthy. We say we need nurses, yes. And we say we need teachers, of course. You cannot do anything else without the engineer. You want a big house, you call a civil engineer, your architect, right? And you want your car, someone has to design it. And one day I hope we will have that sort of knowledge transfer in Jamaica to do it here. But in the meantime, we are exporting you. Our engineers are over there, like I was there, designing these things, right? So it is happening, but it's just that we are not doing it now in Jamaica, but the time will come. So I want us to value our engineers. And in fact, in some countries, you go by the title Engineer Brown, Engineer Josephs. In Germany, for example, in Kenya, this is a normal part of how society is structured. Such is the value put on engineering. I wish to also acknowledge our keynote speaker, Dr. Nadine Maitland. I tell you, when I first came here, there's something called a broadcast, and I kept seeing this person pop up speaking about artificial intelligence. I don't know where Dr. Maitland has not been invited to speak on the topic. And I'm so proud of her because a lot of her talks have been outside of the country, outside of UTech. So I'm glad that we've now brought her home to speak at such an event, right? And there are other members of our faculty who are doing this, right? I'm singling her out because it's her day today, but I know others are doing it. I can see others in the audience who are also sharing their specialist knowledge out there in the society. So I want to congratulate you, Dr. Maitland, on what you're doing. Keep doing it. Your son is here. We're going to forgive you because he's not here studying, but instead he's next door. So we're going to forgive you for that one. But I hear he's also doing some great things at UA, and I know he will come home. I know, you finished the PhD, and I know you will come home, right? So watch this space. And so I also want to acknowledge the union leaders who I'm seeing here. I thought, well, I'm sure it's a distinguished lecture. I don't have any negotiations today. But Dr. Maitland gives great community service as a member of the union, and so I want to recognize Ms. Janet Grayson, president of UTASA. That's the union that represents the administrative staff, and also members of UTASU, which is the union that represents the academics who have come out to support. I'm glad to see you here. We remain friends working on a common initiative, one project, and as Project UTech. To all our specially invited guests, I can see other members of staff, lecturers and faculty, and to our students, good morning. Now I know that intro was a bit long, but the speech is shorter, I promise you on that. As I said earlier, I'm really pleased to be here and that we're talking about these topics. Because if any of you have been listening to me, we have to be clear on why universities exist. We have produced over 60,000 graduates, quality graduates, and we have exported them, and some have stayed here. They work everywhere. They turn on your lights at JPS and keep them on. They turn on your water at NWC. They're in ministries, departments, agencies. They're in the private sector. In fact, I'm told that our engineers are being gobbled up by the financial sector in Jamaica, Sagicor and the rest, NCB and so on. So UTech graduates out there. But I wanted to make it very clear that UTech is not here just to produce work-ready quality graduates. That's not the sole objective. We are here to solve the problems that our nation face, problems faced by the region and globally as well. And this is why it's important that we must become research intensive. We must, notice I'm emphasizing, and we're going to go on that journey. And my faculty and academics know that we are not quite there, but that's fine. Rome was not built in a day. But in terms of clarity of where we need to go, I want to be very clear that's where we're headed. And we will work together to see how that is structured and how that will happen. Because, look, you don't want to be like other top universities. And many of you will say, yes, of course. You cannot get there unless you're producing high-class research. It is not possible. If I go to anyone and say, well, we're producing top-quality graduates, well, they say, so do we. The distinction is the research. MIT, Georgia Tech, you think it's the teaching? It's the research. But I don't want us to do research just for the heck of it. UTech must be solving the problems we face, and there are many. Today is a case in point. We're talking about earthquake. And UTech must be producing the solutions. UTech must be writing. When the government says there's a problem, they must call here first. No more foreign consultants. But if UTech does not give them the confidence because we're not publishing, because they don't see anything coming out, they're not going to come here. They might go next door. But we're going to bring him home, right? Dr. Maitland, he has to come here, you know that. All right. They might go next door. That's fine. We're not competing with next door. I want them to come here. So I need us to do research. When we ask our undergraduates to do their capstone projects, can it become a research project? Can you publish? I want our academics to look at how can we in the short term produce more papers. So I want to see coming out of this, the distinguished lectures, yes, and then the research plan next. The collaboration, the funding, draw down money from RDF. And over the next 5 years, Dr. Stewart, our lifelong academic, we should be seeing a string of papers behind you and your staff and your students on earthquake, resilience. And we must do it because we want to do what? We want to save lives. We want to save lives. So I just wanted to say that because as we go through transformation at UTech, I take all these opportunities to clarify what is in my head so that no one is ambiguous about where we go next. You know, the hardest thing for any company, any head of a company, is to transmit your strategy. You go and ask anyone in UTech, what's the strategy of UTech? Me don't know. It's the hardest thing, and it's not UTech only, any company. You will come up with the best strategy on paper, but to translate it, to get it out there inside the organization is really hard. So on research, I hope this morning, as I close, we are clear that we will become research-driven. We will add value to this institution and the nation by doing that. And our students will benefit, because if you're doing research, then they will also be at the cutting edge of what's next. And it must be applied research. So let me end by just congratulating the team again, Dr. Stewart, Professor Marva Blankson. We were at University of Nottingham together. right? You came there to study and came back home, and I'm so proud to see what you've achieved. You weren't professor then, so congratulations. And somehow, again, look like you're going to follow in Dr. Stewart's footsteps, a lifelong academic. That's fine. We don't mind. It's not only politicians who can carry on forever, right? So we're gonna show them that academics can do it too, and add value at the same time. So congratulations again. I look forward to hearing from Dr. Maitland. I'm excited. I think this is the first one I've attended, despite seeing many of them being advertised. And artificial intelligence, let me just say that at UTech, we will embrace it because it's here. When I was a student, I got my first email address in 1996. I still have it, although Gmail has now taken over, but it's a Yahoo account I had in 1996. Email emerged, and email is still here. Artificial intelligence, the generative form of it, is here, and it will remain here. So we're going to have to embrace it, use it, right, and see how we can eke out the benefits. And I'm sure at some point, the ethics and the regulation of AI will be a topic for Dr. Maitland to touch on at some point. All right, so enjoy the lecture, and thank you so much.
Thank you, Dr. Brown. As engineers, we know to punch the numbers when it comes to loads and structures and steel and concrete and all of that, right? We know to design shear walls and brace systems and base isolators when it comes to earthquake resilience. However, the world is moving much faster now. That has been around for some time, but the world is moving ahead. And so we are now at AI. And today we are here to learn how AI can aid us not to replace what is already being done or what we have learned in school, but to aid us to make our work and our efforts even better. And so I'm going to be asking Miss Denise Allen, lecturer from the School of Computing and Information Technology, to introduce for us our guest lecturer. Welcome, Asika.
Thank you, Mr. Cummins. Dr. Kevin Brown, President of the University, Dr. Balvin Thorpe, our Vice Dean, Mr. O'Neill Josephs, our Head of School of Engineering, distinguished guests, esteemed colleagues, ladies and gentlemen, good morning. It is my esteemed pleasure to be introducing to you today's speaker, Dr. Nadine Barrett Maitland, a luminary in the field of computing and information technology. Dr. Barrett Maitland serves as a senior lecturer in the School of Computing and Information Technology here at UTech, where she has distinguished herself through her dedication to teaching and research. With an illustrious educational background, she has earned a PhD and a master's degree in computer science at the University of the West Indies, Mona, and a Bachelor of Science degree in computer studies with management from our very own UTech. Her research is deeply rooted in information security, artificial intelligence, and leveraging information technology to enhance the quality of life. Dr. Barrett Maitland's scholarly contributions are extensively documented through her numerous publications in peer-reviewed journals, conference proceedings, and book chapters. Additionally, she shares her insights as a guest columnist for the Jamaica Gleaner, where she discusses contemporary issues in technology and its societal impacts. A devout Christian, Dr. Barrett Maitland embodies the principles of lifelong learning, integrity, and service, both as a professional and in her personal life, where she's a proud mother to 3 children. Of course, Doran is sitting right there. Dr. Barrett-Maitland has frequently been invited as a guest speaker where she addresses topics related to computer science, information technology, artificial intelligence, and cybersecurity. Her presentations are renowned for their depth, clarity, and relevance, making significant contributions to the discourse on technology and its role in society. Today, we are privileged to have her share her knowledge with us, and so I ask you to join me in extending a warm welcome to Dr. Nadine Barrett-Maitland.
Good morning, everyone. To President Brown, Dr. Balvin Thorpe, Dr. Stewart, the person who arrested me and asked me to be here, and he would not stop until I say yes. Mr. O'Neill Josephs, head of school of engineering, my friends and sisters and brothers that are here, students, I see some of my students are here. Yes, some from UWI and also from UTech, they are here. My friend and sister, Sister Grayson, she's here with me. So, as Dr. Brown says, we are here together. And I thank everyone for being here with me this morning. And thank you for the confidence that you have placed in me to ask me to participate. I'm looking at a gentleman up there. Is that Mr. Paul Gaynor? No, he's not. There's a gentleman from UWI, from the School of Computing. I keep looking up there and saying that person look like Paul, but I'm not sure it is him. My son is here, and my daughter should be here shortly to support me here today. So today, please understand, I'm not a traditional speaker, so just allow me to flow in the best way I know. So today our distinguished lecture will be on it is about earthquake resilience. Are we ready? And when Dr. Stewart asked me to speak in this forum, what came to mind was AI. And I said to him, we'll go by the topic, artificial intelligence, smart resilience engineering. As I go on, you will see we're computing, and I am going to support my president this morning, but I will tell my president that engineering was it. And I say it again. Engineering was it. But today, IT is it. And how we are going to bring together the two disciplines, because I agree with him that everything has to be engineered. Everything must be engineered. However, today, engineers need technology to make their discipline relevant, easier, and also to drive development. We're going to talk, the first thing I'm going to talk to you about today is about technology. The advent of digital technology is revolutionary. And we cannot deny that, because technology has become so important to society that if we leave our phones, we feel like we leave the world. If technology is not it, and AI is not it, I would like my president to leave his iPad or his tablet or his phone and see what happened. Right? Thanks for coming, my daughter. Thanks for turning up. I just called your name. Today, it is like it's impossible to live without technology, and we can acknowledge that. People leave their handbags and don't leave their phone. When I say to my students, you have allowed technology to take you over so much that you come to class and say you forget your text and you forget this, but you don't forget your phone. They say, Miss, remember, can I use the phone to call and ask somebody to carry it? Right? Technology touches every aspect of our lives. Technology touches it. And that is what makes it so... I'm a Christian girl, you're Biticus. It's almost omnipresent. It's everywhere. The advent of the Internet of Things and Industry 4.0, where man and machine can communicate, has changed everything that we do. So we can actually drive home and turn on our refrigerator, turn on our stoves. You know that can happen? We can drive home and say, turn on the light. Technology, engineering, but technology too. Right? I'm not going to get into it with my president today, right? Right? But we are here, right? And I'm saying it is equally important. You know, I was saying to my students earlier this week about how technology has changed everything and how we have new jobs. Jobs are being replaced today because of technology. And some of the jobs that are here now, they were not even here about 20 years ago. Like we have cybersecurity engineers, data scientists, you had them, but they were in small numbers. Today, that is the thing. Right? So we have to get with it. Now, our smartwatches that we wear, and anybody who know me know that when I wake in the morning, I like to look at my smartwatch to see what quality sleep I got. That's AI. It tells you have slept 85% more than other persons with this device. AI is everywhere. And we're going to talk about it today. And I heard an earlier speaker, they spoke about telecommunication and so on. Right? Now, AI was here long ago. A lot of people just start talking about AI since ChatGPT. Everything is ChatGPT. I'm tired to hear it. But it was here long ago. But it has evolved. And it is taking over basically everything that we do. We can put anything in ChatGPT and ask it and it tell you. Sometimes it tell you that, I don't know. Right? So it's not all-knowing. Right? So we say AI began long ago. We have some early programs. One of the biggest tests that we have, and today our lecture will really be looking more on the development of AI, where we are today, an earthquake, and how it can assist with resilience. Now, one of the forefathers of AI, John McCarthy, he says the science and engineering of making intelligent machines. So here is it, intertwined with engineering. We are building some things, right? We are building programs. The Turing test was one of the earliest tests in terms of the AI, you know, where Turing says, if a machine can respond and you don't know that you can't differentiate if it's a machine or a human being, you can say it is intelligent. And he also said we don't need emotions to be called intelligent, you know. So it's long ago. Work began in earnest in artificial intelligence in 1956. A very few of us were born that time. And how we are today, what is happening today, it seemed like AI just started. So where will we go? That's very interesting. I have a working definition here that I want to share with you, right? That AI is about decisions. We make decisions every day, and what we are asking any artificial system to do is to make some decisions for us, right? It's about using robust data sets, right, and computer science, enabling problem solving. Because we have some problems, and one of the problems we have that we are going to look at today is how do we predict hurricane, earthquake. Now, Mr. Stewart, Dr. Stewart, sorry, sir, asked me to look at earthquake in resilience and recovery. Seismic. My daughter told me that is seismic. Seismic, resilience and recovery. Right? And I was looking straight at her when I was going to say it, you know. Is what happens when a disaster takes place. When an earthquake happens, we have disaster. The ability of a country or a community to return to where it was before the quake takes place is that we call resilience. In dialogue with Dr. Stewart, we spoke about Turkey, and he spoke about it earlier. How quickly Turkey could have returned to their everyday life. It had to do with resilience, right? Systems are considered to be less or more resilient depending on the ability to come for the country or the community to return to normal. There are several factors as it relates to resilience. We have ground motion intensity because that has to do with the earthquake, how the earth is moving, the quality of the building. We just heard Mr. Stewart talks about putting dampers and things in the building. And, you know, when I was building, I couldn't read the plan properly, but I know that we're supposed to have some strap in the house to ensure that if earthquake comes and, you know, the building will rock. Going through the research I saw where some of the methodologies looked at how can a building stand up in face of shaking, right? And that is one of the things, and the quality of the work that is done on the building. So resilience and recovery is looking at how can we keep our country or our community functional, right? After an event. And resilience is the key to us returning to normalcy. So previously, we have a lot of predictive models that were used to determine how resilient or, you know, how strong the thing will be, how can we return to normal. But researchers have suggested that it is still a difficult task because of the things that are involved in predicting these models, right? So they really suffer from accuracy. They are not as accurate as we would want them as it relates to predicting the event. And it is highly dependent also on socioeconomic environment and outside hazards, you know, things that are in the environment. And another thing that happened is that it is very dependent on experts' input, human expert input in the predictive modeling. So machine learning, no, we are not up to machine learning yet. Over the past decade, several research have been looked at. They look at assessing resilience and critical infrastructure and against natural hazards and, extreme events and so on. Quantity and quality assessments have been done, deterministic and probabilistic techniques, and so on. They have tried to use all of that. Some of these things, they said, what makes resilience in terms of the attribute-based approach? So we just look at the predictive approach. We are now looking at attribute-based. And we said robustness, resourcefulness, adaptability, and recoverability. Those are the things that makes resilience. However, most of these things have to be used together, right? Performance-based approaches have been used. I assume a lot of our engineers and researchers would know about these performance-based methods that people have tried to describe the input and the outputs, what will happen based on these inputs and so on. And the performance-based method continue. Now, to my topic that I'm going to delve in today, AI in resilience and recovery. Now, early work was done in AI to try to determine full resilience. How can we determine that an earthquake will come? How can we, what do we input? What are the things that we must input in the system to get some accurate output? Now, some additional work was done. So a study was done in China that looked at some data, old data, they call it retrospective studies, that use data from between a particular year and to model and to help to see how they can predict predict hurricane, earthquake. Now, the predominant technique that is used in predicting earthquake is machine learning. Machine learning is a subfield of artificial intelligence that is used to predict earthquakes, and we'll see what happened. The system, we use programs, we program inputs, we program some inputs, and we check to see if the outputs are accurate. So we have different types of learning. So here we go. We have different types of learning. We have supervised. Machine learning is broken up in some subcategories. We have supervised learning, where there's a teacher. So you tell the machine, so you program what you want, and you have some specific outputs that you are matching it against to see if it is accurate. We have semi-supervised learning, where part of it is done using a teacher, and part of it the machine learns. You have reinforced unsupervised learning, no teacher involved, so the computer is expected to, based on some techniques that you give it, should learn and add and do some things. And we also have something we call reinforcement learning, where the computer learns based on mistakes that it makes, and when it gets the correct information, then you design rewards for it to get, so it can add what the correct thing is to the knowledge base. Now, earthquake engineering, there's something that we call earthquake engineering and artificial intelligence. A comparative study was done that looked at several artificial neural networks to see how accurately can these networks predict the occurrence of an earthquake. Now, for an artificial neural network is designed to operate like neurons in the brain and so on. So where weights are used instead of neurons to communicate throughout the network. So we have several artificial neural networks that were tested to see which one of them could accurately predict an earthquake. So they use a multi-layer perception model where data flows in one way, so there's no backward propagation. Data goes in one way. You have some input layers, so when you input the information, it is processed, a mathematical formula, process it inside. You can have several inner layers. You can choose to have one if it's small, the data is small, but if it is larger, you use multiple layers inside. Multi-layer really speaks about all of the layers are connected. So if you have two nodes and it's going into two other nodes, the two other nodes would have four things. So you have each node is connected to everything inside of the network. So it is a layered network. And then you use some mathematical formula to calculate the signals as it enters into the network, and then it is normalized, and then the output is sent to you, to the outer layer. So you can have a multi-layer, just have 3 layers. You can have a one that have 4. So based on the size of the data, though, you'll design how many inner layers you would need to determine what output you would want. You have adaptive neural fuzzy inference systems, where I know you would say fuzzy appear in a lot of places. So the input is broken down at the beginning before it enters the network into different pieces, and then it is sent inside. So you can have 5 different layers, you can have 4 different layers, but the inner layer, the 4 inner layer, is where all of the calculation is done. So you input, but all of these, I want you to know, these are supervised learning methods. So you actually label the data to go in. So you are teaching, you are training. The large language models that we use today is an example of a supervised learning model, where you tell the model what you want. So the information is actually uploaded to the model, and it is labeled. So it's if the person put in brown dress or something like that, these are the possible outputs. So you teach the machine what you want to output, right? But there's a mechanism in there that tests to see whether or not it is accurate, right? And then it's in. And if it is not, if the output is not as you want it, you can retrain it. So you can send it in again, retrain the machine to output what you want, to see if it will give you the output you need. This network, though, can be very time consuming. It also requires input from experts along with the information, and it is not able to learn. That is one part. That's a fuzzy system. However, the artificial neural network can learn. So what the fuzzy neural, the hybrid fuzzy neural system does, it combines both and utilizes the strengths of both models. The regression, the general regression model, it is said you should always do a regression test, and once you write any code to ensure that whatever you have added is correct. So regression testing is one of the last things you should do in anything that you design, to ensure that what you have added has not changed what was there or allow that to be corrupted or something. You must do regression testing. And regression testing is the last test that is done before you release any system, right? It's proven to be. But the general regression neural network, it uses a Bayesian network feed-forward technique, where for a Bayesian network, we call it a causal network, where you say, this causes that. So we could say if we have heavy rain and there's flooding, then it can lead to this. And this, it can cause flooding, and then flooding can cause, we can have persons hospitalized, we can have homes flooded, it can cause death and so on. So this operates like a network like that. Now, and the Gaussian process regression is another level of regression testing where the Gaussian function is used to complement the regression model. And we have support vector machine. This is one of the more simple methodology or artificial methodology that is used to process data. And it is said if you have a small data set, this is ideal for it. One of the things is that for the most part, it will be accurate, it is easy to learn, and it is easy to be adopted, right? So all these methods were tested. Random forest was also tested, where you use several decision trees. So random forest uses the decision tree concept where if you have one decision tree, it is easier for you to get errors when compared if you have several decision trees. So it combines the result of several different decision trees, and it gives you the output. So all of those artificial intelligent or machine learning modules were used. Random forest is one of the most widely used machine learning technique, because in finance, they use it to help to predict the likelihood that you'll have a default payment. So when you go anywhere and they ask you for your information and they say, what do you have here, what you have there, and the calculator say, you may not be able to pay this loan, or you may not be able to. So for large organizations and financial institutions, they use random forest technique to determine who will default on the debt, who will go forward. Yes, for like credit. Anything that most large financial organizations are now using random forest to determine. And it is said that it is more accurate than all of the other models. In medicine, they use it to determine what's the likelihood that somebody who have this will survive based on all of these parameters that we input. In economics, it can also use to help to predict if a policy will be effective or not. In earthquake engineering, it is used to predict whether an earthquake will occur or not. The aim of the study was to determine which one of them would be best suited for predicting earthquakes and so on. The experiment was set up. This was done in China, and they used some data from a particular database, and they determined, like we say, if it doesn't predict it or don't do it, stop, reprocess, and come again. Now, this is what they found. The ANFIS, along with the random forest, I spoke about it earlier, the support vector machines, these were more accurate than the GRNN and the next method. What they found, there was a possibility to develop a machine learning model that could be substituted for the expert opinion that we depend on now for many of the predictive models. Secondly, it is possible to utilize machine learning and some recovery function by imitating and replacing the expert that we now depend on. Now, here's a use case. So in in a region in China where earthquake is prominent, so earthquake occurs regularly, there was a competition for people to come up with AI system, right, to see if it could predict the earthquake. Over 30 weeks, the experiment lasted for 30 weeks. For the 30 weeks, remember a while ago I said the random forest technique is a very widely used technique because of its ability to predict things and to analyze data more accurately. 22 of those 30 weeks, the random forest technique predicted the earthquake accurately. Yeah? And the study before, I said it was a retrospective study, but they actually use real data, real-time study, that's what they call it. 30 weeks within the zone, and they use signals that are coming from the earth and all of those things. And the random forest technique predicted it 22 weeks of that 30-week experiment. It predicted it accurately. They inputted electromagnetic waves and geocaustic, using geocaustic sensors to get the information that they would want from the environment. And then it was placed in the machine learning model, and that is how they could predict the earthquake accurately. It forecasted it 73% of the time accurately. Between the data from 2016 to 2020 was used using real-time data during 2021. So they had that data and they used some real-time data. Overall forecasting accuracy was 70%. Precision recall and F1 scores were 63, 93, and 75.66% respectively. So how good was that machine, that method in remembering what it just processed, or the signals that just passed through it? The technique remembered it 93.3% of the time, right? And the F1 score is where you combine both precision and recall. So the overall accuracy was 70%. In Israel, a research was done by a university that looked at, can we predict earthquake? Earthquake of a magnitude greater than 6. They tried to predict. Remember a while ago I said the support vector machine, it is simpler. If the data is smaller, you can use support vector machine. So they use that because it was an initial test, right, in Israel. And it is said that the negative predictions can be achieved using 85.7 accuracy, and the true negative was 85.7, and the true positive predictions at the accuracy level of 80%. This is just a 2-minute video. They said I can just call them. So they are coming to give us a call. All right, so we're not getting the video, but we'll just go back to the presentation. From current side, from current. All right. So we have seen that we have AI models that can predict earthquakes at least 70% of the times. So we have proven that through research. Now we are going to look at building impact assessment. Can we use AI to do assessment on buildings after an earthquake? The ability for us to, and Dr. Stewart spoke about it earlier, the ability for us to go back to whether the new normal or to normalcy, to where we were before, is very important after any disaster, right? And these tools such as ShakeMap and ShakeCast was developed in the United States to support, assessing buildings and so on, where they take information from different places. They are on a platform and they can get information from different locations. ShakeCast provides real-time estimates based on certain things. ShakeMap combines knowledge from ground motion and recordings within the earthquake magnitude and so on, and they combine it. It was developed as a one of them, ShakeCast, was developed to complement ShakeMap, right? And we also have ASOS that is used that can help to provide real-time estimates in the case of an earthquake. Now, an experiment was carried out in 2020 because they wanted to see how could AI help with assessing building damage after an earthquake. And several machine learning techniques were used here, as I said, in South Napa earthquake. Data from that earthquake was used, where they put in, for example, how long it stayed there, the age of the building, how many floors, because research shows that the higher the building, the more it's easier for it to tear down compared to the lower the building, the density, and the lower it is to the ground, it is safer compared to a higher building and so on. We have techniques that are modeled using just single floor and so on. The Napa earthquake in 2014, it was a 6.0 earthquake. So what they did, they classify, I think if you watch the videos, you'll see when they are trying to identify damage on business, so they put some colors and so on it. Dr. Stewart shaking his head, so it seemed like I'm saying the right thing, right? And so on. So some training sets were used, right, to determine how accurately could the AI predict damage on buildings, right? These are the results. Using random forest, same one we spoke about, it could have identified, it was accurate 66% of the time in assigning the correct tags, and 79% of the actual yellow tags in the process was tested. It also noted that a good prediction can be obtained even when fault distance and age and so is left out. So you could leave out some of the parameters and input some, and it still gave you good results. Random forest, again, has proven to be a very accurate method, machine learning or AI method to use in the assessment of buildings. The research showed that more work needs to be done to enable widespread adoption of machine learning algorithms in earthquake-induced building damage predictions. Right, so it was a very small study, but it proved that we could use machine learning techniques to identify damage on buildings. How can AI be used in search and rescue? After a disaster, after an earthquake, the ability to analyze and summarize images and so on AI has the ability to draw information from all over the place, from social media posts and other posts, from satellite sources, and so on. And it could also help in identifying places that we would not be able to identify just with, depending on human to call. Because presently, many places we depend on people to call to say, this happened and so on. We could use artificially intelligent deployed tools to assist in search and rescue. This was an earthquake in Turkey, and a tool called XView2, an AI tool, XView2, was used in the Turkey situation. And this picture is an image that shows where the damaged buildings are and so on. The darker red identify where the damage is and so on. And the AI tool was used to identify this. It employed a technique close to the object recognition tool and segmentation, semantic segmentation. We have something we call semantic networks in AI. So they use machine learning algorithm in conjunction with satellite imageries from other providers and brought it together, and they could identify damage in disaster areas. It could also say the severity and all of that. It evaluate each pixel to say where the adjacent things are, and it allows them to draw conclusions, and the conclusions, for the most part, were accurate. XView2 has been used by at least 2 different teams of search and rescue personnel from the UN advisory group, rescue advisory group. It's supported in areas where residents have been frustrated by the delayed arrival of search and rescue teams, so it could pull the data from there and send it to a central location so people could be aware that, So let us say in Jamaica, we have constraint as it relates to resources. We may not know which area is best for us to go at what time, So to deploy our limited resources, we could know that we need to send 20 people over there. We need to send 10 there or 2 here, right? So the potential to identify where the resource is needed and the amount of resource that is needed at a particular location, it helped to do that. It also helped persons to find areas that are damaged that you would not necessarily know just by, looking, or maybe somebody could be unable to even call you from there. So you may say, I wasn't even aware that the damage was there, right? So we could use this tool to do that. AI drones were used in 2019 after a deadly earthquake in southern Europe to locate survivors in rubble, according to this report. In the 2016 earthquake in central Italy, AI-powered drones were used to assess the extent of the damage and supporting decision makers, like I just said, prioritizing the areas that we need to deploy people and so on. AI can help in the management of evacuation. So we could use AI tools to map out the routes that people need to take. We have places, for example, in Jamaica, that is densely populated. What if, after the earthquake, there's a collapse somewhere? Somebody don't have to drive and go there to see it because maybe no one is there. We could use AI tools to know that persons from this area need to take that route, and so on and so forth. And the routes that are, that are full, we may be able to deploy them somewhere else to get them out of the zone. So AI tools can be used. So because it can bring together traffic cameras, GPS, and things coming from social media and so on. Because we know, I don't know how many of us ever talk on our phones and say something, and you start seeing some ads coming to your phone, and you're like, who listening to me? That's AI, right? So I'm telling you, so even on social media, you go on social media and you may say something, and so it can combine all the information coming from different places, right? Remember earlier I said where we talk about 4.0 technologies and the talking and so on. AI can help authorities to manage traffic flows. I spoke about that. It can help evacuation teams. So, for example, in the hurricane in 2018, in North Carolina, AI was also used to help with the evacuation of the persons there. And similar systems have been used in Turkey and in Syria to help people to evacuate during the earthquake. Benefits of AI in earthquake and disaster search and response. Over the past 5 years, this tool, it has been deployed, and we talk about it has been used in wildfires to support the team, resource team in wildfires. The Nepal flooding event, the President just spoke about it. It creates that landslides were there. It could help to identify persons that were underground. Because you know that our watches, many of the watches today, they are made with some AI tools in it that it can be programmed and connected to like emergency units. So based on the impact that your vehicle get, emergency units can turn up, right? So based on the force of the impact, the watch will record it and send the signal to the emergency unit, whether it be ambulance or whatever, once it is connected on the internet. It is scary. It is scary, but it is good, right? Because you could be in an accident and nobody knows. But based on the impact of that you got, whether your car, whether, you understand me? Emergency units can turn up and help to support you. That's AI. It has been used in Turkey, Nepal, and Australia because it can create a shared map of affected areas in minutes, which can help organizers to create something, a strategy of how they will deploy the resources that they have. And that can save lives. The traditional methods that are used, where people waiting on eyewitnesses and calls. I've received a call from Portland to say that so-and-so bridge is down. I've received a call from Westmoreland to say that and that is down. They could have known that in the center from before if we have AI systems and smart technologies connected to things like that, right? So the potential is there. Assessment by humans sometimes can take days and sometimes weeks, for it to be done. The assessment can be done in minutes. And sometimes the level of accuracy sometimes can come into question, right? It can be further slowed by different organizations. They are operating in silos. So my system may not be talking to yours, your system not talking to mine, that one not talking. So I have information, but if I don't call you and give you, you don't get it. Or if I don't send it to you and the same thing. But AI can bring together all those silos and bring to bear a result that we can use when we need help. One scientist, it said it can help first responders significantly. Aid in quick assessment, I spoke about that earlier. The benefit of XView 2 is to cause quick response and so on in the case of earthquake or anything like that. And it's a huge milestone. We didn't have that before. So the AI tools are being developed, they are being deployed, they are used, and we have seen the benefits of them. Challenges. The technology for sure is far from a cure-all. Challenges are, first, it is important, for example, what will communicate with the model. So it is said that the first usable diagram or image that came out of Turkey came, I think, about 3 days, after 3 days, because if we have cloud cover and things like that, it can affect the image, and it may not be as clear as it should be, and several things can affect it. However, that's room for improvement. The first, I spoke about that 3 days before, after. So persons who are in certain areas, disadvantaged, or economically disadvantaged, they may not have certain things. The image taken in remote areas were not as clear. So the present version depends on aerial view. And it may not be able to spot cracks like on the side of the building, right? So because it uses aerial view, it may not be able to spot damages on the side of the building. Adoption of the AI tool. Most first responders, they are very traditional. So they are having problems in people using this tool. So awareness, education becomes very important. So when you start telling first responders about it, they may not trust it to say that it may not be able to do because it is new, right? So that is one of the challenges that we face. The future, it's in the early stage of development. It's an open source tool, the programmers, the computer persons here. As a matter of fact, most persons here may know about open source. It's an open source tool, so anybody can use it. According to the scientist, he's been encouraged to sell it, and he's saying, no, it should be something that people can use to develop whatever is there for the social good. So the developer is saying it's an open source tool, and is a tool that we can use in our arsenal to help us. The code, I spoke about that. Rather than writing off or overhyping the role of emerging technologies, we can play in big problems. Researchers should focus on the types of AI that can make the biggest humanitarian impact. Because we don't need to write off everything. And we don't need to say, no, it can't. Let us see how we can adopt some of these tools and deploy them in the spaces that we have in order to support us in our arsenal. And that's we are talking about the importance of research. Our president just spoke about research and development. This is an important point that we could adopt this open source tool and see how we can employ it in our domain to support us in regions, for example, in developing regions and so forth, where we don't have a large amount of resources. It could certainly support us in our endeavor. These are my references. Thank you for listening.
I'm sure you can do better than that. Thank you. Oh, yes. Right. Are there any questions? I'm sure there are. There are students here. They're good. So is there any mics on the floor? Or you may need to use my mic. No, well, I think we're on YouTube, so we may need to record it. So let me just pass this around.
Okay, good morning. Oh, good morning, everyone. Or good afternoon, I should say. From an ethical point of view, what would you say are systems that could be implemented to be used as a guide so that it doesn't, our personal information doesn't get in the wrong hands, seeing that AI has become the new it, as you have stated?
The new norm?
Yeah.
All right. I'm very sure my student up there was going to ask that question. I actually teach ethics. So Privacy issues are evident. And one of the things that we must put in place is regulations in terms of use of data. How will it be used? When will it be used? And so on. So worse, we have Data Protection Act now roll out. People will have to give consent to say my data. But I'm telling you now, in times of disaster, people don't remember. People don't remember that their data, what they want, they need help. So there are some things that we call legal basis, public interest, and so on. If our information need to be used based on the interest of the public, and the government may need to use it in order to save lives, but I think we must put in some regulations that will guide the use of information in general.
Any other question? Forgive me, my foot is not so.
A gentleman up there. Really?
All right, good afternoon again.
Afternoon. Afternoon.
Dr. Maitland, you mentioned that ML,
Machine learning.
gives, the experiment has shown it has 66 to about 70% accuracy
No.
in detecting damage to...
22 out of 30. 22 out of 30.
Okay,
Yeah, yes.
it was 66%.
66%,
right?
yes.
Accuracy.
Detecting damage
Right, in
on buildings.
infrastructure.
Yes.
I assume that the input would suggest that you would assume that the building is built according to code, a certain code,
Yeah,
and
ma'am.
according to a certain standard. However, in Jamaica and in some other societies where we have vulnerable communities, where structures are not really built to code, right, and are in some instances substandard, how would we account for this? What input would you use to account for that?
Hold on, let him finish.
Within ML.
All right, so these parameters are things that are fed into the system. Remember when I was talking, I said we could remove age, is one of the things. We could also remove, certain parameters can be removed, and it was tested. Hence, maybe it came out at 66. So that is one of the things that the research show, that the workman, the quality of the work that is there, it also affects it. Like you said, the quality of the building, the quality of the material, and so on. So several parameters were used in the testing, and they actually pulled some and tested it, and it could accurately do it at the level that I spoke, and they also put, so sometimes it was higher. So let us say the building is properly built and so on, it would be higher. If you remove some of the parameters, for example, what you're talking about, it talks about the quality of the building that has several parameters determine quality of the building. So for example, it spoke about code. Did they get approval? Was the building code properly assessed? And things like that. So all of those parameters are things that are used in the testing and that make it go up and down. It averaged at 66. Maybe if everything was on point, maybe it could have come out higher. And I'm depending on Dr. Stewart to finish that response in terms of the building code for me, if I didn't answer it to his liking. What you get out, yes? Yeah. Oh, okay, sir. Thank you, Mr.
Yes, good afternoon, everybody.
Afternoon.
My quick question is, in regards to machine learning, you mentioned something about the machine being able to learn unsupervised. Could you just shed a little bit more light on that, please?
All right. So we have different machine learning techniques. For most 99.9% of the techniques that are tried in terms of testing whether you can predict earthquakes and so on, they are supervised learning. That one, the teacher inputs, and the teacher know what the output should be, and then based on if it doesn't work. The one that I talk about, I'm just mentioning the different techniques. You have a technique that we call semi-supervised, where a part of it, the machine is told what to do, and it is allowed to learn and add to the base, right? There's another one that we call unsupervised, so there's no teacher at all as it relates to that. So the machine will just learn on its own and input. Then we have another technique that we call reinforcement learning. Now, just a little part of the AI, we have systems, if we build systems that are able to learn and add to the knowledge base, we call those autonomous systems, autonomous agents. Right? If the agent is unable to learn, we say it lacks autonomy. So if we are building, so that's why we say the literature shows that over 90% or 90, I would say 90, they don't find any yet that uses semi-supervised or unsupervised learning. For the most part, the techniques that are used are supervised learning. And I mentioned the large language models that we use today, and that is why you see the answers are generated a particular way. It is trained to do that. So the information is placed there, and it is trained to respond to you in a particular way. Yeah. Somebody, there's a gentleman at the top.
Good day.
Good day, sir.
I sigh a bit with the whole AI in our lives and the whole issue of AI learning by itself and expanding without control. How will we protect ourselves from this creature which we have created and has the potential to become untouched? I think there are movies which have somewhat illustrate some of the challenges which we can face, which we are fast approaching. I had an experience this week only where I have on my phone Samsung, and it has this feature called Health Connect. I do daily recordings of my activities, including my steps and my food, only to realize that after about 2 weeks, before even inputting any food, my phone was telling me that my daily calories for my breakfast was X. And I'm now wondering what went wrong. But luckily I picked up and I went back into so Samsung has this S Health, so it's not something which is strange. So I went in and I looked for it and it says unknown source. And I went back to when I think I enabled the feature and I deleted all of them. And I was relieved to realize that before eating breakfast now, it remains at 0. So if I did not catch that 2 weeks down, can you imagine after a year? And could I have reversed that situation?
All right. Now, the AI will only learn as much. I'm glad that you said that you went in and you saw it and you untick it. So this is what is important. We must pay attention. The AI will do as much as human beings have programmed it to do. We have 2 types of AI that we say. We have weak AI and we have strong AI. Weak AI are the systems that we must put information in and so on, and it learn a little thing and say about it. But strong AI is what you are talking about. Somebody here said eliminate us. We are not there yet. We are not there yet. The academic definition for artificial intelligence is that it varies along 2-dimension thought and action, where is either you're thinking rationally or acting or thinking humanly or acting. Now, the other thing is that the system will do as much as we program it to do. So they had programmed it to do that, but you didn't know and pay attention. So now that you pay attention, you stop it, right? So you realize that it's not really automatically taking it because you didn't realize that you gave it permission. So here is it now. We must pay attention to what is going on because if we don't address it, we will end up giving permission for things to be done that we don't. So you see, when you go on the things and you want to use the program, them right now, students, so you say, next, 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 next. You're actually giving permission for many of the things that you see happening, right? So the AI will not grow as much as you allow it to grow, but we are human. We have programmed them, you know. So for now, so far, all the systems are built by human beings. Right? So that thing about we are going to be extinct and we are going to be this and that, it's a fear, and fear comes many times because of lack of knowledge and so on. So in strong air, it's in textbook. Now you see them move where you watch and so you see them something there. However, it is developing, so we don't know. All right. So I'm glad that we are so aware now too, so we will take charge and hold on to our dignity.
Yes, good day.
Good day, sir.
I am Damien Hibbert. I'm a civil student under the tutorship of Dr. Cummins here. My question is, you mentioned that we are not there as yet for the AI to be
strong
AI to take over, as the gentleman suggested earlier. My question is, how far away are we from that?
All right. So let me talk to you about that. One of the challenges we are facing is for people to really track the cognitive processes. Remember, a doctor can operate on you and they can operate on your brain, but they can't operate on your thought. That is where the difficulty lies. And even though I'm an AI teacher, I'm a Christian too. And I know that God makes us different. And every single one of us in here, we are different. And the thought, until man can capture the thought and program the thought process. Because every decision that we make it because of something embedded in us, you know. I made the point earlier that AI is about decisions. We make decisions. When you get up in the morning and you decide to get up and come out, you made that decision based on something that you have done over a period of time. Right? And that decision is made because it is somewhere. It's somewhere in the thought. And as one philosopher says, if somebody just takes some things and match it, like, oh, we put it in the computer, we program the robot to say, or the chatbot to say this, or we program ChatGPT to say this. The philosopher said, if the machine is just responding based on what we have programmed it to do, for example, an expert system that doctors use, and, and so on. He's saying, if I give Mr. Joseph here a paper with some rules, and I speak Chinese, and I give him the rules, and I give him some things, and he can use that rule to match it. And when him finish the puzzle. Would you say that he knows Chinese? No, he's just following some rules to get there. So unlike Turing says you can be called intelligent without emotions, and we don't want to get down all of them philosophy story there. But we are aware of those things. And we are saying strong AI, why it is so far-fetched now, even though man is trying to do it, we must be able to capture the thought and program that thought, because we all make decisions, and when we make decisions, we make it differently. I make a decision different from Dr. Stewart. And Mr. McLean make different decisions. And it's really based on something that he has, right? And he made the right, and he made the right decision when he's financed this, right? So I'm very glad that he made the right decision. Thank you, sir.
Thank you so much. Thank you so much, Dr. Maitland, Barrett Maitland. I just want to make a point. I know that I mentioned earlier that, the Hollywood has caused us to have this amazing mindset around AI. But just to get back to what the lecture was about today, and in terms of looking at AI, in terms of earthquake awareness, etc., prevention, etc., not prevention, prediction.
Prediction.
And I bring in, recently we had at one of our property, we were trying to determine getting insurance for the property. And what was interesting is that if we were supposed to insure the property for earthquake, etc., what the insurance what they call it, the excess deductible, the point, how much you will have to find in the event of an earthquake, make it almost prohibitive to insure the property for earthquake. And so it begs us to look now, so perhaps having a tool that can give a higher level of confidence that the likelihood of a significant earthquake event within a particular geographic space is minimized, may also allow us to have better opportunities, and especially as a small island, vulnerable economies like us that requires reinsurance facilities externally from the UK, etc., it puts us in a better space if this can be enhanced and we get to the point where our vulnerability can be better predicted, then the cost of us ensuring these vulnerabilities can be better in the future. So that's something that, that
Thank you.
Certainly.
Yeah, so research again. So if we can really do some research on how can we build using this open source tool to develop tools. Here we are, the engineers that build everything. We can look at how we can use these AI tools to enhance what we are doing. I saw my son looking with curiosity because earlier when I started the research and I was saying about predicting earthquakes, he said, Mom, I don't think that I'm glad he's here. I encouraged him to come here, but I didn't tell him why. Because I wanted to tell my young scientist that artificial intelligence, is it, right? The possibility exists for us to predict earthquakes. It may not be 100. It is not where we would want it to be, but technology is getting us to a place. Thank you.
Thank you so much. Thank you so much. And don't leave. Don't leave. I was just looking if my name is on this plaque, but it is not. Come, I'm going to invite your daughter and your son to join us on this platform. Right, so inviting family. Should I invite Janet, Grace Nelson? And Miss Allen, Denise. I mean, from ever since I know you, I know Miss Allen. Come, Denise. Two on the right and two on the left. Come, Denise. To accept. So it's a community of support accepting this award for the presentation today. Dr. Barrett Maitland, you did an exceptional job in presenting on a very difficult topic. It's a very difficult topic, and those models don't exist everywhere. They're very rare. Only in China, I know of that model existing, and we're learning now of a particular model to predict damages to building in the States. So excellent job in digging out that material, finding it, presenting it, and understanding it. I'll forgive Mr. Cummings for that anomalous question, but certainly all other questions were excellent, and you responded very, very well to the questions. Very good presentation. Thank you very much. On behalf of the team, planning committee, our sponsors, which I'll mention later, we want to thank you and just give you a token of our recognition and appreciation of this presentation. Thank you. Thank you very much. All right, you've gotten that, sir? All right, great. Excellent, excellent. Now, this was a good day. The team has done it again. The Civil Engineering Department in their series, I mean, this concept about resilience is a very good one. I think you're on to something, Percival Stewart and the team in the Civil Engineering Department. How we respond after an earthquake. What do we do? How do we prepare? Our response in the case of an earthquake is what we're talking about today. And today we touched on a very important and topical topic, AI in the recovery process. And we heard a very good presentation. So first of all, let me just take the opportunity to thank our guests, those present today for coming out, students, staff, friends, family, and all the works who have made the time to be here with your friend and colleague. Thank you very, very much. Let me also thank the planners and executors of this event. Again, the Civil Engineering Department in the person of Dr. Cummings, I was told earlier, and Dr. Percival Stewart. I know when these events are being delivered, there is a whole team of students who are part of the planning and execution. And it's one of the things that Dr. Stewart does very well to be able to pull support. When I looked at and I'm coming to the sponsors, I said, okay, interesting. So yes, a very big thank you to the team for the work that they have done. Put your hands together for Dr. Stewart and the Civil Engineering Department for the work that he continues to do. It's a vision, it's a vision that he has, and he's executing on that vision. And, the good thing about a vision is that so the old man dreams and the young man have vision. So he has the young man. Forgive me. Right. Okay, good. But let me also pause to recognize our sponsors. Without the sponsors, we couldn't do it. I don't know how he continues to do it, but he continues to get some big wigs in the room. Let me point out clearly our sponsors, JSIF. Put your hands for JSIF. Today we have, in terms of JSIF, Senior Communications Consultant, AC White, who's always here when we're having these events. Stand and let us see you. We have Dane McLean, who is Project Manager for the DVRP project. Stand, Mr. McLean. Good. Senior Project Manager. And we also have Engineer Ricketts, past President of the JIE, who is quietly supporting us at the back, who just asked the question. Thank you for coming, Mr. Ricketts, Engineer Ricketts. So that's our main, I'd say, title sponsor. But then we also have some other important sponsors, such as the CL Environmental Consultants. Any representative from that entity here? And by the way, well, let me not say that.
They are not here, but we got them money. And their banner is outside.
And their banner is outside. So they're not here, we got their money, and their banner is outside. I'm not sure if that's the message we want to send them, but but we want to say thank you. The principals of CL Consultants. Right. Catherine Peak, I had one of the waters earlier, so I'm not sure if that's the only. Well, they've sponsored, and we thank them so much. But also maintenance, IDC Maintenance and Construction. I don't know that entity, but I want to take the opportunity to also thank you for the contribution that you've made to yet another successful event. And I'm sure the other in the series will be just as successful. But let me pause a little bit and reserve perhaps the more significant thanks to our guest speaker today. And as I said earlier, put your hand. Was able to do a very difficult job, what it has done for me personally, it has given me some insights as to the data sets that are required to drive the predictive models, whether the predictive model is going to be a random forest machine learning predictive model, that is going to help us to understand when an earthquake or where an earthquake can actually take place, or that is a building assessment model. And the question about building code was a tricky one there. Yeah, I'm going to talk to you after this, Dr. Cummins. But again, another very important modeling there, using the same random forest predictive model. And then you also touch on the search and rescue modeling. So 3 things she really ironed out today for us: prediction, assessment, search and rescue. So stuff such as routing, using data from your networks, your communication networks, to understand what's your location, high density locations, the environmental condition of a particular location, and how best to deploy our resources is an absolute excellent area of understanding. And even if we don't go the more difficult side of the predictive models, which I think is a complex side, we can certainly take the softer sides, such as the search and rescue and so on. So very, very good tools here to work with from that presentation. So a very good presentation all around. Thank you very much, Dr. Nadine Maitland. Our friends who are in virtual land, this is the end of another excellent lecture series. I want to thank you for joining us, and I want to invite you to look out for the next in the series of earthquake resilience from the Civil Engineering Department. Thank you, thank you, thank you.